Okay, good evening, ladies and gentlemen. I think there has been a little change in Zoom, so I'm just figuring out what are the changes. So you are observing a little new background, so let's begin with announcing the successful people first of all in this week, and then we'll start our session. Okay. Yes. Good evening, Kiranji. Let's join hands together to first of all congratulate all the successful participants this week. Let me first announce green belt participants. Mr. Ajinath Bade, congratulations, Mr. Bade. Salam Deepak Singh, congratulations, Mr. Deepak Singh. And Bennett Sandeep, congratulations, Mr. Bennett Sandeep. And Suraj Govind Bhagat, congratulations, all these 4 participants completing green belt certification successfully this week. Okay, and we have got 3 black belt successful participants this week. Mr. Akshay Kadam, congratulations. Mr. Gagan Mohan Sharma, congratulations. And Mr. Ronak Joshi, congratulations. And all the very best for your next venture. Okay, congratulations to all of you. And let's begin the journey. Why I announced this names? Because I want to motivate other people as well who have not yet completed their certification. Okay, so today's session is about control charts and what do they do basically. Okay, yeah, congratulations to all of you. Super. Yeah, so let me just share my screen with you and let's begin the topic of the day today, which is nothing but decoding the control charts. First, let me cover some of the fundamentals, just try to understand what is the importance of control chart, when do we use it, and how to calculate the limits, etc. What is the logic behind that limit, why it is set at plus and minus 3 standard deviation only, etc. All those things basically we will discuss. Okay, chalo, so let's start. About the topic which we are going to discuss is control chart. See, the objective of the live session is to go deeper into the concepts. Okay, understand this. Concept might be the same, but we'll go a little deeper. And as we go deeper, our understanding widens, and so our understanding of application as well widens as well. All right. So this is very, very important. Santoshji, your transcription is available in our LMS system. It is available on our YouTube as well. So I don't think few other transcription, outsider transcription is required. Okay, superb. So let's understand this, which is control chart. Now there was a person whose name was Walter Shewhart. Okay, and Walter Shewhart was basically observing the variability of various processes. He was a statistician and he was basically collecting a lot of data, and I am talking about almost 100 years ago. Okay, yes, father of control charts, father of statistical process control, I would say. So he was collecting data and he was observing a lot of patterns and the trends of the data. Okay, he was calculating a lot of things, and from his whatever work he has done, whatever study he has done, whatever came out of it is what we are calling today is control charts, and or we can say statistical process control. Okay, the science which got developed because of Walter Shewhart's work is called as statistical process control, and as Kiranji rightly mentioned, he is called as father of this statistical process control. Now see what he observed. He observed that every process has a variation. That we all know, right? Every process has got some kind of variation. Now, if we plot any process, now when I say process, okay, let's talk about whatever we plot, that is called as voice of process. What is voice of process? Voice of process is nothing but data. Okay, what is voice of process? Data. Whatever data we collect. Now, what kind of data we collect? We collect a lot of data in our process, right? So we collect production data, we collect sales data, we collect customer, what you can say, the average call handling time data. We collect downtime data. So there are a lot of data we collect during our processes. Now that is called as voice of process. Whether my process is delivering the result properly or not, I will get to know from the voice of process. That is nothing but the data. Now, when he was studying the data, he observed that data has inherent characteristic which is called as variation. Whichever data we have, right? We have continuous data, we have discrete data, whichever data we have, variation he observed, which is constant. So he started plotting the data's variation one by one. He started taking averages of it, and then he found a pattern. Okay, then he found a pattern. For example, let's say if I start plotting the data like this, okay, let's say everyday production or everyday sales, if I start plotting, so it will look like this. If this is the graph, and let's say day 1 the sales was 100 pieces, then day 2 150 pieces, then 135 pieces, then so if I keep on plotting, I would get a trend like this kind of variation. And he observed that this kind of variation is there everywhere. Okay. So after analyzing these patterns and trends for so many experimental data, he found out there is a center which we call it as a mean of the data. Just a second. Yeah. So this is the mean, which will be the center line. We call it as X bar line. X bar is nothing but the mean line. Okay. And he found that it has got some variation as well, and that variation can be measured with standard deviation sigma. Correct? Now he started finding out standard deviation, and he found that majority of the processes, okay, almost 99.7% of the data, okay, will fall between plus and minus 3 standard deviation from the mean. Okay, that means majority of the data will be lying between these two bands, and he named those bands as upper control limit and lower control limit, UCL and LCL. So what is the formula? X bar plus 3 standard deviation, and UCL is upper control limit, make a note of this, and LCL is lower control limit. So X bar minus 3 standard deviation. He surprisingly found, after so many observations, that data is more or less, it's fitting into this, and very small amount of data, which is 0.3% of the data, is going outside of these control limits, and he started calling them as special variation. Okay, so the data within these limits, he started calling them as common variation, and the data going beyond that limit, it's called as special variation. Right? So that means so he just made sure that, okay, so within these two bands, it's common pattern. Outside this band, there is a special pattern, a special cause, easily identifiable cause. But within this common pattern, it is difficult to identify the cause. Are you understanding? Now, he observed, then the question arises, why 3 standard deviation, and why not 2 standard deviation? Why not 4 standard deviation? By the way, before we go into that, are you with me till now? Just give me quick yes in the chat box. Are you getting this? Just give me a quick yes. Okay, so we are just going into the roots of it, from where this entire study has come up, and why are we doing this? Okay, clear? So he started analyzing a lot of patterns and trends. He found that within this plus, so why he froze plus 3 and minus 3? This is very interesting. Okay, now this is where we go deeper. Okay, otherwise in the real, yellow belt, green belt level, we would have definitely said there is a control chart, and control limits are set at plus 3 and minus 3 standard deviation. Now in the live session, we are going deeper, why plus 3 and why minus 3. Okay, now when he observed, if understand this, He said this variation is called common variation, right? Common variation. Okay. Now, when basically he started putting, let's say, plus 2 and minus 2 standard deviation. That means instead of plus 3 and minus 3 standard deviation, if he reduced the the band to plus 2 and minus 2 standard deviation, what he observed, lot of data points are going outside of the control limits, and there is a fear of changing the process again and again and again and again. Are you understanding? Understand this. Just try to understand. The moment you see, why do we put control limit? That is the limit. If any data goes out, we take action. Yes or no? Everybody just give me yes or no in the chat box. Why these limits are set? If any data goes outside, we immediately take action. Yes or no? Now what Walter Shewhart do? Walter Shewhart reduced the band, and then he observed one very interesting thing. Okay, so he did all the experiments. So he reduced the band to plus 2 and minus 2 standard deviation. He observed now people are taking more actions which are not required. Are you understanding? And that is basically sabotaging the process. How many of you understood? Now the moment if I reduce the band, that means there are more data points which are going outside. More data points going outside, that means more action you are taking in the process. And because of more interactions in the process, more disturbances in the process, okay, you are actually sabotaging the stable process. So after he realized that if we reduce that band, people are taking it, they're overreacting to the variation which is natural in process. Naturally, that process variation will be there. If we start overreacting on that, it is actually sabotaging and the variation is increasing. How many of you got this? Just give me yes in the chat box. Are you understanding? So it's like super micro management of the process, which is not good for the process. So we are tweaking the normal process. So what he decided, so after experimentation he observed, I will repeat this. See, the question what we are answering here is, why plus 3 and minus 3 standard deviation control limits are set by Walter Shewhart, right? What you observe, instead of plus 3 and minus 3, let me just remove this. Let me remove this, okay? And let me just quickly draw this once again. Just try to understand this. And that's good that you guys are asking the questions, okay? Let's say this is my X bar, okay? This is my X bar, and my process is like this, and this is my average, okay? This is my average. Now this is my X bar plus 1 standard deviation, okay? This is the band. Then this band is X bar plus 2 standard deviation. Are you understanding? Just try to understand this, okay? And then we have X bar plus 3 and X bar minus 3 standard deviation. Just a second. Clear? So this is X bar plus 3 standard deviation line. This is X bar plus 2 standard deviation, and this is X bar plus 1 standard deviation, okay? On the back side, on the lower side, which is X bar minus 1 standard deviation, X bar minus 2 standard deviation or 2 sigma, and this is X bar minus 3 sigma. So our upper control limit is set at X bar plus 3, and our lower control limit is set by X bar minus 3 sigma. Clear? Have you understood this diagram? Just give me yes in the chat box. I will explain what is D1, D2 because people will get confused here. Are you clear? Just give me quick yes in the chat box. Okay, now, so the question comes, after studying lot of processes, he observed that majority of the processes are stabilizing within +3 and -3 sigma. Okay, so if we collect the data, what he observed within +3 and -3 standard deviation, almost 99.7% of the data is falling, and 0.3% data is going outside of the limits. Okay, that is what he, so maximum data is falling within this. So he called that this is what is the common pattern, common variation. So he named this variation as common cause variation. The variation which is within these plus and minus 3 standard deviation. Okay, now why only +3 -3? When he observed, if I put, let's say for example, this is a natural variation of any process. What is natural variation? Just to give you example of your office arrival time. Okay, you come to the office, you reach to office, sometimes 5 minutes early, 5 minutes late, 10 minutes early, 10 minutes late. This is called a common natural variation. Okay, but if one day, if you come 1 hour late, that is a special variation. That is a special cause, right? So after understanding, he found that within 3 plus and minus 3 standard deviation, the process is showing a common pattern of variation. That's why he set up the control limits at plus and minus 3 standard deviation. Now the question I was explaining, why only 3? When he set up at plus and minus 2 standard deviation like this, okay, he observed lot of data going outside. Now can you see here, this data is going out, 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 right? Here also this data is going out, this data is also going out, this data is also going out, or very close, right? So people were actually overreacting. Let's say if this data is going out, if immediately you will change something in the process. You will increase the temperature, pressure, speed, etc, etc, etc. Correct? So actually, for the stable process, people started overreacting and started sabotaging with the stable process, and that was creating more variation in the process. That's why after experimental, he decided that let's stabilize these control limits and plus and minus 3 standard deviation. Are you clear? Just give me quick yes in the chat box now. Okay. So rather than setting it at +2 or -2 standard deviation, he set up at +3 -3. Okay. So in the technical term, okay. Why not +4 -4? +4 -4 will be, then you will be too complacent in that. Understand this, huh? This is also very good. Why only 3? Why not 4? If you increase this, so even if the process goes out of +3 -3 standard deviation, okay, then you will not do anything, and there would be a probability that the process can go outside of the specification limit and create a defective rejection, right? That's why he decided, let's fix it at +3 and -3 standard deviation. So it's a complete balance. So what is a technical, what you can say, if this question is asked in the master black belt level, actual technical correct answer is this. Okay, to balance, make a note of this. Okay, to balance alpha and beta error, write this down. Okay, just make a note of this. I will explain it to some other time. Okay, so at +3 and -3 standard deviation, this what you can say, this kind of errors of the judgment, whether we should take action or not, right? So alpha and the beta errors are that, so which we cover it in the hypothesis testing as well, right? So at +3 and -3 standard deviation, alpha and beta error are balanced out. They get cancelled out, and it creates an equilibrium at +3 and -3 standard deviation. So these are the technical explanation of this. Okay, is it clear for us? What we need to remember is at +3 and -3 standard deviation, the control limits are set. Clear? Just give me quick yes in the chat box. Just make a note of this. Okay, chalo, so आगे बढ़ते हैं. Now this is control limits, which checks whether the process is having the common variation, and or having a stability or not. This is called as stable process. Okay. So these are errors. See, alpha and beta are the errors. For example, I'll just quickly briefly explain you. If I have 100 what you can say products, okay, let's say 100 water bottles. I'm checking water bottles. Okay, I'm a quality person. Just briefly I'm explaining. Okay, I will take 10 out of 100 is a population. I will take 10 samples. I will check it. Now imagine the what you can say, the water bottles, 100 water bottles are all, they're very good water bottles, but I have selected some bad water bottles out of it. Are you understanding? Okay. So the lot is good, the population is good, but there are few defects, and in the sample all the defects have come. And because in the sample those 3-4 water bottles were defective, those have come, I have rejected the entire lot. Actually the lot was good. There are only 2-3 bottles were having some small defects. Otherwise almost the lot was good. I have selected all those defective bottles in my sample somehow, and that's where a good lot was rejected, and that is called as a alpha error. When I am rejecting a good lot, that is called as a alpha error. What is beta error? Let's revert the situation. If there are a lot of defects in the 100 bottles, okay, but in the sample none of the defects have come. Are you understanding? So the lot is bad, but I am declaring that the lot is good. So I am making error in the judgment, and that is called a beta error. So I am accepting a bad lot when it has to be rejected. That is called as a beta error. Okay, just a simple example for you to understand and appreciate. Clear, everybody? So to balance out these errors, basically, alpha, plus and minus 3 standard deviation was set up. Clear? Yes, everybody, just for your understanding. Exactly, type 1 and type 2 error. So alpha is type 1 error and beta is type 2 error. That's exactly the same thing. The nomenclature is different. Absolutely right. Clear? Okay, so let's move ahead from this. Now, this is the process. Now understand this. When customer says whether my process is within the specification limit or not. Okay, now this is called as control limit. Now, who decides the control limit? Type in the chat box. How did we calculate the control limits? Who decides this? Is it Walter Schubert who decides this? Is it the customer who decides this? Is it the head of the company who decides this? Who decides the control limits? Or I am deciding this? Okay, customer, quality assurance, process. Okay, type in the chat box, everybody. Who decides the control limits? Result, okay, process, customer. Very good. So the answer to that is, who decides the process itself? The process itself decides the control limits, because if you calculate this, what are we calculating here? X bar. How do we calculate? From the data. Then we calculate sigma. How did we calculate? From the data. Are you understanding? So process data itself. So process data, which is nothing but voice of process, itself will decide the control limits. So upper control limit and lower control limits are decided by the process itself. There is no customer requirement we are considering here. Okay, customer requirement we have not considered. Only how the process is flowing. That's it. What was your daily production? Not what customer is asking. If customer is asking 1000 pieces every day, we are not considering that here. How much are we producing? That data we are collecting. That's why the process data is deciding the control limits. And who decide the specification limit? That is decided by the customer. Are you clear? The specification limits are decided by the customer and control limits are decided by the process itself. So now let me just quickly make this, just take a screenshot of this, by the way. Just take a screenshot quickly. How many points are required? So any kind of process what you can say analysis, minimum collect 30 data points. See, you can do it lesser than that as well, but minimum 30 data points you should consider. Okay, any kind of calculations you have to do, control charts, histogram, box plots. Okay, the mean, mode, median, and what you can say your standard deviation. So minimum 30 data points are required. Okay, now let me just quickly draw this. So let's find out what is the difference between control limits and specification limits. Okay, just make a note like this quickly, and we will do some specification limit. Okay, specification limits. All right. So control limits and specification limits. So control limits, we call it as voice of process, which is decided by the voice of process, which is nothing but data. Correct? And specification limits are decided by voice of customer, which is decided by the customer itself. So this is what? This is by the process, and this is by the customer. Correct? Here we use control chart. Okay, so like this, now we use this just like I just showed you, correct? So this is called control chart, right? And here we use histogram. What is histogram? If you remember, if I plot like this, I will put specification limit like this. So this is upper specification and lower specification. Okay, so if the data goes outside of the control limit, it is called as a special cause variation. Okay, and if the data goes beyond specification limit, it's called as what? Type in the chat box. If the data goes beyond specification limit, this one, this data and this data is called as what? No, this is see, if the data goes beyond control limit, it's called special cause variation. Within control limit, it's called common cause variation. Let's not get exactly. So it is called as out of specification or defects or rejection. Okay, so this is called as rejection or defect. Clear? Now the data which is within control limits, it's called as common cause variation. Common cause variation. Okay, and the data which is within the specification limit is called as what? Within the specification data is called as what? Type in the chat box. Everybody. हाँ, कंट्रोल लिमिट के अंदर है वो कॉमन कॉज वेरिएशन है, स्पेसिफिकेशन लिमिट के अंदर है वो क्या है? एक्सेप्टेबल. एग्जैक्टली, इट इज एक्सेप्टेड. एक है रिजेक्टेड और एक है एक्सेप्टेड, और यू कैन से ओके प्रोडक्ट, राइट? ओके प्रोडक्ट, एक्सेप्टेड प्रोडक्ट, which is confirming. Non-confirming meaning outside of specification, confirming meaning accepted. Correct? Clear, everybody? The data within control limits is called common cause variation. The data outside of the control limit is called special cause variation. Okay, let's focus here. Let's focus on this part. Let's talk about control limits here. Control charts के ऊपर बात करेंगे. Anything which is within this band. Okay, this one. Within upper control, so this is called upper control limit and lower control limit. Anything within this band, it's called common cause variation. Anything which goes outside of the control limit is called this one, this data point, it's called as special cause variation. This one. Are you clear, everybody? Just give me yes in the chat box. Everybody with me? Just give me quick yes. This is about the control charts. Now let's come to the histogram. Let's come to the specification limit on the right hand side. Now anything within this one, it's called accepted product. Anything which goes beyond this part, it's called rejected product. This one. Clear? So one is called as control limits, one is called as specification limit. Shantanu ji, shall I repeat it once again? Focus on the control limits. Once again, control chart. Anything which is within the control limits, it's called common cause variation within the control limit. If it goes beyond control limit, special cause variation. Let's come to the specification limit. Specification limit decided by the customer. Okay, we will take practical examples. Okay, हम लोग मिनी टैप पे अभी करके देखेंगे. Specification limits are decided by the customer. Correct? Now, anything which is within the customer limit is accepted by the customer. Anything which goes beyond specification limit is rejected by the customer, because specification limits are decided by the customer only. Let's say pizza delivery. If customer says, I will accept pizza within 20 to 30 minutes, this is the band. If you deliver pizza, even let's say example lete hai, even if you deliver before also customer will reject. Consider that. Okay. If you deliver at 18 minutes also he will reject. If you deliver after 30 minutes also he will reject. That is called specification limit, 20 and 30 minutes. Or a cup of tea. Customer accept within 90 degree and 70 degree. If you give cup of tea beyond 90 degree, that will be too hot. Customer will reject. If you give below 70 degree, that will be too cold for the customer. Customer will reject. Customer will only accept the cup of tea within 70 and 90 degree. That is called specification limit. Clear? Everybody clear with this? Just give me yes or no in the chat box. Clear with this very simple example? Now the same example, if I take the temperature of the cup of tea, I will plot it on the graph and I will take the average. I will calculate the standard deviation. On plus and minus 3 standard deviation, I will plot the control limits. That will become my control chart. I will not consider specification limits here. I will not consider the customer requirement here in the control chart. Clear here? Just give me yes in the chat box. So control chart is all about process. Specification limit is all about customer requirement. Clear? किसी को भी डाउट है तो मैं फिर से एक्सप्लेन करूंगा. अंडरस्टैंड दिस, डोंट वरी. ठीक है, तो एक करके देखते हैं बेसिक कंट्रोल चार्ट. आई विल शेयर अ डेटा. हमारा रेगुलर, हमारा सबसे पसंदीदा चॉकलेट का डेटा हम लोग लेते हैं बिकॉज वी लव चॉकलेट. सो या, वेरी गुड, वेरी गुड. थैंक्स फॉर कंफर्मिंग. जस्ट ओपन दिस फाइल क्विकली and we will do some exercises here. Okay, yeah, the same file I'm sharing twice. It's the same file. Okay, open karte control chart bana ke dekhte, then we'll see what are the different types of control chart, and then we'll go a little deeper into within control variation also. This one. Okay, can I apply same example for control chart T temperature? Exactly, yes, the same example can be used for the control chart. Yes, same data can be used for control chart specification. Only limits will change, na? Only limits will change. The same data. Correct? Chalo, let's open this file. Let me also open the file. Once you open the file, please let me know. Acha, ye nahi. This is something else. Where is my data file? Okay, there are a lot of data. Just a second. Opened, everybody. Just give me a confirmation yes in the chat. Super. Okay. If you're traveling, not having laptop with Minitab, it's okay. Just observe what we are doing and All right, done, opened, very good. Chalo. So let's make a simple control chart which is called as, first is individual control chart. Okay, so how do we do that? Go to stat, quality tool, sorry, stat control charts. No, it requires Windows, Neeraj ji. It requires Windows. मोबाइल पे नहीं होगा ये, आपको लैपटॉप या डेस्कटॉप चलेगा, कौन सा भी पुराना लैपटॉप चलेगा, डेस्कटॉप चलेगा. ओके, सो स्टैट कंट्रोल चार्ट्स and individual control charts, individual, just follow this path please. Stat control charts, variable charts for individuals and individuals. First एक बार basic control chart करके देखते हैं, and then I will go deeper into other types of control charts. I will take couple of examples and then we'll open for question and answer. Okay, stat control charts, variable charts for individual. Okay, so this window will come and just select chocolate weight, just double click on chocolate weight, that's it, and click on OK. If you got this, just give me quick yes in a chat box. Now let me draw. So let me draw these three lines here. See, this is x bar plus 2 sigma line. I'm just, this is x bar plus 1 sigma line. This is x bar line, which is the mean line, and you have got x bar minus 1 standard deviation, x bar minus 2 standard deviation, and this one is x bar minus 3 standard deviation. Okay, correct. Now only one data point you can see is just touching this control limit, otherwise the process is fairly stable process. Are you clear with this? Just give me yes in the chat box. Clear? So what Walter Shewhart says, if the process is within these two bands, na, control limits, process के साथ छेड़खानी मत करो. Do not tweak the process. That's what he said. Okay, let the process flow within this. It's a stable process. Correct? This is called as a stable process. Clear, everybody? Now let's go deeper into this. Let's go deeper. There are few tests also we can do. As I said, we'll go a little deeper. Now plus 3 minus 3 standard deviation ka band we have understood. Within this we have got some additional test also we can do. What are the tests? Let's go back to this edit last dialog box. Okay, you can see here edit last dialog box, or you can just press Ctrl E. Just press Ctrl E and you will get this last dialog box in front of. Just press Ctrl E. Okay, and just click on options here, eye chart options. Just go to eye chart options. Everybody with me? Eye chart options. With me, everybody? Just give me a quick yes. Okay. Okay. Now in this eye chart option, go to test. Okay, there are a lot of options: parameter, estimate, limit, test, stages, etc. Go to test. Clear? Now this window will appear. Everybody with me? So here, if you just click on this drop down option, you will see perform all test for special cause, perform selected test for special cause, perform no test. All right. So what we will select? We'll select perform all test. All right. Click on all test. So all test will get selected. Now you click on OK, and now you click on OK. Now the same graph, there are few more red dots being appeared on this. And plus it has got some numbers also like 6, 5 and 1. Repeat करो फिर से एक बार. Yes. See. Have you plotted the first graph? जितेंद्र जी, have you plotted the first graph यहाँ पे? ये वाला ग्राफ आपने प्लॉट किया था, ये वाला. Yes, correct. Now उसी के साथ what we can do, just press Control E. Just press Control E. Okay, the same window will appear. See, Control E is the shortcut. Okay, you can go to the if you don't want to press Control E, just you can go back to the again the same one. Okay, the stat, control chart, individual chart, and individual. If you go there also, you will come to the same window. Okay, now go to eye chart options. Go to eye chart options, and here you can see test. Can you see here? Limits, estimate, parameters, stages, etc. So here is something called test. Click on test. And in the drop down menu, select perform all test for special cause. Once you click on this, you click on OK and you click on OK. Yes, click on OK and then click on OK. So you will get this test done. Now what is this 651? Just try to understand this. Clear? Now let's want to see what are these tests. So let's go back again to Control E and open this eye chart option and go to test. Now there are a lot of tests written. What are these tests? Test number, there are 8 tests. Okay, there are standard 8 tests in this. Now what it says, 1 point beyond 3 standard deviation. Now here there is something called K. What is K? So you just have to replace this K with this number. Everybody with me? So whatever they have written here now in this, okay, you have to just replace this value of K with this number. Okay, for example, how do I read this? 1 point greater than 3 standard deviation from the center line. Now what is the center line in this graph? Type in the chat box. What is the center line in this graph? In the control chart, what is the center line? What is that? The mean, the average. Correct? Very simple. The average. So when we say center line, that means the average. So 1 point beyond the 3 standard deviation. Correct? 1 point beyond 3 standard deviation is the first test. So if you see here, if I close this and close this, can you see 1 point here? This one. So this one red meaning the test number 1 failed here. 1 meaning test number 1 failed in this dot. That is, this dot is going beyond 3 standard deviation from the mean. That's why it is 1 written. Are you clear? Just type yes in the chat box. Clear everybody? Okay. So similarly, if you remember, I had drawn these dotted lines for you, no? I'm just drawing it once again, just for your understanding, okay? Just for your understanding. Correct? Now let's talk about test number 6 and test number 5. Let's try to understand what is test number 5 and test number 6. Okay. So now let's go back again. I have to actually clear it off again once again. And let me go back to the test. Now let me count test number 5. Okay, 1 2 3 4 5. So what is the test number 5? K out of K plus 1. Now so what is the K here? 2. K value is 2 here. Okay, so 2 out of 2 plus 1 point, that means 2 out of 3 points. 2 out of 3 points beyond 2 standard deviation from the mean. 2 out of 3 points beyond 2 standard deviation from the mean. That means, let me now go back. Understand this. Now here what these tests are telling us, see, this is called common cause variation, na? This entire band is called common cause variation. Correct? Common cause variation. If it goes beyond, it is called special cause variation. Right? What these tests are telling us, within the common cause also, can you find out some patterns which can become in the future, which is the probability of becoming special cause? तो ये पैटर्न वो हाईलाइट करके दिखा रहा है. आर यू अंडरस्टैंडिंग? सो दिस इज पॉइंट नंबर 5. टेस्ट नंबर 5 fails. It shows that 2 points out of 3 going beyond 2 standard deviation. So if you remember, I plotted now 1 standard deviation, then 2 standard deviation, right? So here you can see this is point number 1. Understand it. This is point number 1, this is point number 2, and this is point number 3. Can you see here? So 3 consecutive points, 1, 2 and 3. Out of these 3 points, 2 points are going beyond 2 standard deviation. Are you observing this? Just give me quick yes in the chat box. Are you observing this? This is point number 1. After that, the second consecutive point is this, and third consecutive point is this. Okay, so the third point is going beyond. So out of 3, whenever 2 points are going beyond 2 standard deviation, it means the process is shifting. Yes or no? The process is shifting towards upper control limit. Are you understanding this? Just give me quick yes in the chat box. I will repeat it. Okay, focus here. Focus on this point. After 73, 74 point, there is this point. Okay, are you observing this? Okay, now from this point, what is the next consecutive point? Is this. This is the next consecutive point. After that, this consecutive point. So let's focus on these 3 points only. Okay, so what is our test number 5? Test number 5 says 2 points out of 3 going beyond 2 sigma. It's called test 5 failed. Test 5. Okay, in this case, 1, 2 and 3, out of 3, these 2 points are going beyond. This is 1 sigma, this is 2 sigma, and it is going very close to 3 sigma now. So the software is telling us what you can say in advance, that please check, there is something going wrong, please take action, otherwise it will go beyond control limit. Are you understanding? So it is beforehand, it is giving us the alarm. Are you understanding this? Yes? Correct? So it is like I have put some movement cameras, okay, on my fence. Let's say I have a bungalow and I have put some cameras on the fence. Anybody who is coming close to the fence, I will immediately get some trigger. Similar to the other test. The intruder has not intruded yet in my premise, but that person is having some movement near my fence, right? So I am detecting that. This is like that. Clear, everybody? Now let's come to test number 6. Now lot of these points. Okay, why upper point is not highlighted? Which one? So see, the point is 2 out of 3 na. See, understand this. This is point number 1. Where is that? Okay, this is point number 1, this is point number 2, and consecutively point number 3. See, that means 2 out of 3 points, whenever 2 out of 3 points are going out, okay, so they are highlighting the third point has gone out. That means this is, see, ideally 2 points out of 3, that means if they were highlighted this as well, okay, if they would have highlighted this second point, that means which ones? 3 consecutive point, this and this. Understand this? Okay, why they have not highlighted this point? Because if I highlight this point, so let's trace back last 3 points. So that would be this point, and this point. This point. Are you understanding? Now this one, and this one, this is not fulfilling that criteria. That's why point number 2 is not highlighted. Are you getting my point? Why point number 3 is highlighted? Now you get the bunch of these 3 back consecutive dates points. Okay, right? So this is exactly fulfilling this test number 5, not the previous point. If you go to the previous point, then previous 3 data points, if you go, it is not fulfilling this requirement. Are you clear with this, Neeraj ji? Just give me quick yes in the chat box. If just try to understand. See, what this software is telling us that there is some shift happening over there. Okay, 2 data points up. Now, how did they arrive at this test? Again, the same thing. After a lot of consecutive, what you can say, and this is the advanced science. This is not the Shewhart science, by the way. Shewhart said +3 -3 standard. That's it. All these are the advanced terminology which recently got developed. Okay, after Six Sigma and all the stuff. Clear? Now let's come to the point number 6. Let's go back to the test number 6. What is test number 6? Again, go back to Control E, go to the eye chart and go to the test. What is test number 6 is this. Okay. This is test number 6. So K is 4 here. So 4 out of K plus 1 point, this one. 4 out of K plus 1, that means 4 out of 5 points are beyond 1 standard deviation. 4 out of 5 points beyond 1 standard. That means majority of the, out of 5, 4 points are going beyond 1. That means majority of the process is shifting towards control limits. Okay, upper control or lower control limits. So let's see here. Let me just close this. Okay, let me just close this. Now look at this. Okay. Look at this. So here what it says, 4 out of 5 data points. So if you see consecutive, now again, this is my 1 standard deviation. This is my 2 standard deviation and so on and so forth, right? So 4 out of 5. So if you see here, this data point is the 4th data point here. Can you see? This one is the last consecutive. So this is 1, 2, 3, 4 and then 5th data point is shown in red. Okay, so 4 out of 5 data points going beyond 1 standard deviation. Again, these 3 data points are fulfilling this. Again, this data point is also fulfilling that particular criteria. That's why it is shown. Again, this test basically, we just have to observe whether any kind of movement. Now this means the majority of this process is shifting upwards. Can you see here? A bunch of the data points are shifting upwards. It's something is happening. Something is happening over there. Are you understanding? Yes? Just give me a quick yes in the chat box. See, again, this is the advanced tool. If you want to use it, you can use it. Otherwise, you just have to focus on +3 and -3 standard deviation. Clear? If you go deeper into that, you can switch on the test and observe very micro movements within the common cause variation. That's why these tests are basically built. Clear? Okay. Now let's quickly touch upon if I want to make the stages of it. Okay. If I want to make stages, for example, let me go back to the original control chart. This one. Okay. This is the original control chart. Are you observing? Just observe this, just for your understanding. If you observe this, where is that? The process, okay, here and process here. Are you understanding some kind of shift in the variation? Just give me quick yes in the chat box. I have just plotted 2 kind of stages in this entire data points. Are you observing? In the first half, the variability is a little less. In the second half, the variability is a little higher. Are you just, physically also you can just observe that. Now, if I want to, any change in this process if you have done, so how you can show that in the stages? Okay, let's go back to the data. And what is the data point? Let's say this is the data point number. If you click your cursor, it shows value number, observation number 55. Okay. So I will take up to 54 a different data. Let's go back to the data. How do I go back to the data? Okay. Control Alt D. Just press Control Alt D here. Control Alt D. I'll go back to the data once again. D meaning data sheet. Okay. Now here what I will do, I will just in the C3 column, I will just put something called stages. Okay. And up to 54, I will write. Everybody just with me? Have you got to the data? Yes? Yeah. Now what I will do, I will just make the stages. How do I do that? I will make two stages, before and after. Okay. For example, I have just changed the supplier of the process. Okay. Or I have just automated the process. Or I have done something else. Okay. So I will write before. I will drag it till 54th value point. Okay. I'll just drag it till 54th value point. Same like our Excel sheet, you can drag till 54th value point. And after 50, why 54th? Because we have observed the shift after 54th data point. So after 54th, I am just shifting to after. Okay. I'm just giving you example. Okay. You can use this during your control chart. Okay. Before and after. And I just drag it till the end. Yes, before and after, just like our Excel sheet. Clear? Everybody has created this up to 54 before and after 54 after. Clear? Stages have you created? Just create that quickly. Let's do one experiment here. Once it is done, just give me yes in the chat box. Done. Okay, now we go back to our original one, Control E. Just press Control E here. Press Control E once again. Go to iChart options. Go to iChart options. Now here go to stages. Just beside the test, we have stages. Okay. Clear? Can you see here? Control E करके just go to iChart option. There are stages. Just click on stages and define stages. Just double click on stages here. Clear? And each with each new value, that is, don't do anything else. Just click on OK and click on OK. Can you see here? So there is a different stage on the left hand side and a different stage on the right hand side. So we can compare that. You know, we had supplier A on this side, supplier B on this side. We had manual process on this side and automated process on this side. Like that you can present it. Clear? Just give me yes in the chat box. So it calculates two different. So the moment you put stages, software understands there is some fundamental difference. Okay. There could be two different shifts, two different suppliers, two different people, two different systems, two different, what you can say, processes, and you're collecting the data and you can just put them into stages like this. Clear, everybody? So this also is one of the factor you can use in the control charts. Clear? So what we have understood, so we have understood what is control chart today. Let's quickly summarize whatever we have understood. It's new today. Very good. So let's quickly summarize whatever we have understood today. So we got to know about the Walter Shewhart, the father of statistical process control, correct? Then what he understood after a lot of permutation, combination and experimentation, that any process within +3 and -3 standard deviation is called as a stable process. Okay. So within that it's called common cause variation. Outside of that is special cause variation. Correct? That's what we said. Why he set up at +3 and -3 standard deviation? If we reduce these, right? So there is a probability or there is a possibility of overreacting to the variation, and actually it will be adversely impacting the stability of the process. Just to avoid that, he set up this as a +3 and -3 standard deviation. So technically answering that question, to balance our alpha and beta error, basically that control limits are set at +3 and -3 standard deviation. Then we understood the difference between control limits and specification limits, yes, correct. And then we have understood that in the control limits, so we practically did control chart, the eye chart, right? And then we understood about the test within the common cause variation. What are the tests which we can do so that we can identify the patterns well before the process goes beyond control limit, right? So that is called the test. And then we have understood the stages. If you want to make 2 or 3 stages over there, you can make the stages like this. Clear? So you can make multiple stages: before, after, before, during, after, right? So during our Lean Six Sigma project also, you can do before project, during project, after project. That also you can do. So similarly, in that column of stages, you have to give the name of the data, okay? And then you can click on the stages and it will create a different control chart for you. Clear, everybody? Just give me a quick yes in the chat box. Any question on this? Very good, very good, very good. Superb. So the people who are not able to bulb on moment, very good, very good. Superb, superb. Chalo. So at least the efforts which all of us as a team we are taking, of learning and going deeper into the science of this is try to implement this. My only request to that is try to practice this. Take your own data, whatever we are learning, try to practice with your own data. And whenever you get the doubt, okay, then we have our mentor number 99305, our mentor number, which we all know. Just send a message that we are making this, okay, and we will definitely give you the answer immediately. Okay, yes. So thank you very much. How to copy and paste? Just copy and paste like Excel sheet. Jitendra ji, okay. This is one way of doing it. Another way I will show you. For example, so copy and paste is one way, right? With Excel. Another way is go to File, go to Open Worksheet. Okay. This is another way. You can directly open Excel sheet over here as well. Okay. Now you just want to locate the file. For example, let's say desktop. You have a file. Let me just locate a file for you. Let me Excel. Okay, Excel. So let's say OTIF data. Okay, this is the Excel data we have, and if I click on open, so you can see here this file is opened in the Excel sheet. This one, Minitab. Okay. So you can go to the worksheet, open worksheet folder, and from there also you can open the file directly in the Excel file, directly in the Minitab as well. Okay. So this way you can do this. Clear? So I will share this entire stuff over there, and you can just practice with your own data. And whenever you feel doubts, find connect with our mentor number, right? So tomorrow we have the yellow belt session because tomorrow is Sunday, right? So what you can say, you can send your referrals, referral people, and earn handsome referral amount as well, right? And yeah, new but well understood. Very good, Dilipji. Thank you very much. Okay, anybody see, even if you understand 50% of it, now that's amazing. Just sit with open mind. Forget about whether I know. Just use your basic understanding. That's it. Okay, and we'll repeat again, right? So I think that's it. And we'll connect again on Monday with a new topic, which will go deeper into the concepts. So keep learning, keep growing. This is Diresh Patil signing off, and wishing all my Muslim brothers and sisters, happy Eid, and celebrate your Ramadan, and our all wishes from Sparan and Giving community to you. Okay, thank you very much for joining in. Bye bye. Take care. Good night.